We're now looking at part 3. Okay, so for part 3, it says that the distance between 2 points along a curve is called the arc length. All right, so they mentioned about how arc length is used for scientists and engineers. And then, so how do we calculate arc length? The arc length between any 2 points on a curve where theta, suppose theta equals to beta and theta equals to alpha, is given by this formula. So this formula is pretty easy to understand. All right. So it's the integration of the square root of the x d theta. So the x d theta is what we have found in part 1 when we try to find dy dx. And then we also plus the square of dy d theta, which has been found in part 1 as well. Okay. So now we need to decide what is our beta and gamma. Sorry, this is gamma, not alpha. Okay, the beta and gamma in this case. All right. So basically, simple idea. When I have any curve, all right. So the arc length, let's say suppose here to here, the arc length, this length, we just need to apply this formula, do the integration where theta is this value to theta is this value. All right. So let's apply this formula to our curve C. So our curve C looks like that. So we have plotted it in the previous part. All right. So we need to find the theta value because this curve C. So we need to find the length. So therefore, we need to find what is the theta value here and what is the theta value here, right? So you can use the graphing calculator to help you to do that. Okay, so we are also given a question that the theta is between 0 and pi. Likely that this will be the two end values of theta, all right? But we need to verify that, okay? So you can now pick up your GC, just do a quick check. You can use trace, all right, use trace. So you see that this point here, as you can see, is actually where theta is 0. And then the last point, the end point of the curve, it's where theta is 3.14 something, right? It's pi. Okay, so we are going to integrate from theta 0 to pi. So we're going to now find the arc length using this formula. So our total arc length would be integrate from, so our beta would be 0, gamma would be pi for our, in order for us to find the arc length of C. Okay, so this is our formula. So now we're going to substitute in our expressions. So in the previous part 1, we have found the expression here. So this is 2 minus 2 cosine 2 theta. So we square it. And then plus 4 sine theta cos theta. So the issue is really how to integrate this. It looks scary. Okay, so some of y'all might expand everything and then you simplify. Yeah, that will do too. Alternatively, let us see whether we can convert it to the same angle. So now we observe that we have 2 theta and theta, right? So there's some inconsistency. So it's quite hard for us to simplify. So let's convert the 2 theta to in terms of theta. So the manipulation is the same as what we have done in part 1. So we're going to use double angle formula. All right. So this part here, we will either replace it with 1 minus 2 sine theta squared, or some of y'all factor out the 2 and you can do the same. All right. Okay, so we use double angle formula. The manipulation is the same as what we've done in part 1. Okay. Okay, so we're going to do that. So we have, then the 2 will be cancelled. Okay, so let me write this down. Becomes a 2 minus becomes a plus. And then this will be 16. 4 squared is 16. Be careful in your manipulation. Let's cancel. So 4 squared is 16. So we have a sine power 4. So now we see that we have a common factor. So let's take out the common factor. So common factor is 16 sine squared. So in here we have sine squared plus cosine squared. And sine squared plus cosine squared is a beautiful 1. Okay, using your trigo identity. So we have something very, very simple. Since theta is between 0 and pi, so sine theta will be positive, non-negative. Okay, so this will give us 4 sine theta. So we have simplified until really, really simple. So we are going to then integrate this. Very easy to integrate. So we have 4. Integrate sine is minus cosine. So let's evaluate this. So we have minus 4 cosine pi minus 4 cosine 0. Cosine pi is negative 1. Cosine 0 is 1. So we have 4 minus minus positive 4, 8. So the arc length of C is 8 units. Right.